Chapter 3, we're starting with the rectangular coordinate system with our graphs, linear equations, and our functions, okay? So, when we're dealing with our linear equations, we've got the graph, usually it's a line. We have an infinite number of ordered pairs that all connect together to make this infinitely expanding line. We have several different forms that you will see the lines in. The different forms have different uses. This first one is standard form. Okay? Our variables are together on one side of the equation, and we have it set equal to a constant. Okay? A and B both cannot be 0. We'll see a couple equations where we're missing one of those variables. In that case, A or B is 0. But we can't have them both be 0, otherwise we don't have variables anymore. So we have to at least have one of those variables, but most of the time we'll have 2. Okay? Standard form is most useful for x and y intercepts. Okay? Standard form lets us get x and y intercepts most easily. Then we have other forms like slope-intercept form or point-slope form. They are used for different things. Standard form's primary goal is x and y intercepts. X and y intercepts are just that. Mathematicians, we are not clever in how we name things. X-intercept is where we intercept the x-axis. Y-intercept is the same, but with the y-intercept. A very, very important, simple, but important feature to understand about intercepts, something that is often overlooked or forgotten, is that all y-intercepts, all of them forever, I don't care what equation you're looking at, I don't care how simple or complex it is, its y-intercept always has an x value of 0. Okay? Every equation ever. Y-intercept, x equals 0. So if I have an equation and I want to find the y-intercept, I can just replace x. And that'll let me solve for y. Okay? Same thing with the x-intercept. Every x-intercept known to forever is always going to have a y value of 0, because when you look at the x-axis, the y value is 0. There's no vertical change. So every x-intercept has a y value of 0. All linear equations will have at least one of those. It'll have an x and or a y-intercept. It won't have more than one. Some of them will only have a y, and some of them will only have an x-intercept. So we're going to start with finding our x and y intercepts, and then we want to graph the equation. So I have 2x minus y equals 4. So if I want to start with the x-intercept, what do I need to make y? 0. Okay? Let y equal 0. And the benefit of that is that when y equals 0, that term goes away. It eliminates that term and any coefficients that were there. It leaves me with a one variable equation that is then just one step to solve. What does x equal? 2. Okay? Let's see if I actually put that on. Barely. Okay, now, other very, very important distinction. Intercepts are points. They are ordered pairs. And they have to be written as ordered pairs. If I ask for the x-intercept and you tell me it's x equals 2, wrong. Because x equals 2 represents something completely different. So I know the x value of my x-intercept is 2. And if I want to write my ordered pair, x comma y, and I know the x value is 2, what was the y value? 0. That's what I determined in the beginning. Let's say y is equal to 0. Let's see what x equals when y is 0. And I solve, and there we go. I have my x-intercept. Okay? So it must be written as an ordered pair. You will lose so many points on those questions if you do not write them as ordered pairs. Okay? X-intercepts, y-intercepts, when we do quadratics, vertices, these are all ordered pairs. They have to be written as ordered pairs. Writing it as x equals is telling me something completely different. Y-intercept, we're going to let x equal what? 0. Okay? So for y-intercept, we let x equal 0, and we're going to follow the same process. If I have 2 times 0 minus y equals 4, well, that term just goes away. I'm left with negative y equals 4. So what does y equal? Negative 4. Y equals negative 4. So what is my ordered pair for my y-intercept? 0 for the x value, negative 4 for the y. And then that lets us graph quickly 2 points here and here. And then we've got our linear equation. A couple things about graphing. I try to avoid graphs or sketching graphs by hand on MATLAB when I can, because it is. But when we get worksheets, you will have to graph by hand. So when you're graphing, a couple of things you need to do. Make sure your points are clear. The line doesn't have to be perfect. Okay, so don't worry about that so much, as long as it's close, as long as I can tell where those points are. And don't forget to put arrows at the end. That's left off on a lot of linear equations. Okay, when you're graphing, make sure you put the arrows. Because what do those arrows mean? Put the arrows and you're telling me your graph stops at wherever your line stopped. So you need to make sure you put the arrows to indicate that it does continue. Because if we do piecewise or various things later, there will be times where our graph stops. So we have to indicate. They're small details, but they mean a lot. Okay? So make sure your points are good. Line just has to be close. Include the arrows. Boom, we've got a linear equation. Questions, comments, concerns? All right, let's do another one. This is one of our special equations. What am I missing from this equation? I'm missing x. Okay? So remember I said a and b both can't be 0, but if one of them is 0, then it makes that variable go away. All right? So if I'm looking at standard form, which is ax plus by equals c, in this case, a is 0. It made that x go away. All right? So if I kind of look at it in standard form and I put that x to come back, but I leave it as 0 with the coefficient, I can see it does not matter what I plug in for x, I will always get the same value for y. I could plug in -1 for x. I'm still going to get y equals 3. I could plug in 2 for x. I'm still going to get y equals 3. So regardless of what x is, I always get the same value for y, which means I'm going to have what type of a line? They're all straight. I have a horizontal line. Okay? And horizontal lines have a few special features that we'll kind of add in as we continue going through this section. But y equals some constant will always be a horizontal line. Now, since we're talking about intercepts, lost. Since we're talking about intercepts, okay, what is the y-intercept of that line? Okay, there's my y-intercept. 0, 3. Okay, that's y-intercept. Y. What about my x-intercept? There won't be one. None. Does not exist. Undefined. There is no x-intercept. There's no x-intercept. Because it's a horizontal line, it's parallel to the x-axis. It will never intersect the x-axis. So y equals a constant will be a horizontal line with a y-intercept equal to or located at whatever your constant is. And it's not going to have an x-intercept. Now, x equals equations. So, I need to solve for x. If I have x plus 2 equals 0, what does x equal? -2. If y equals gives me horizontal lines, equals is going to give me vertical. Okay, it's the same idea because no matter what y is, no matter how far up or down I go, x will always be -2. So here, or here, or here, it will always be a vertical line. So x equals some constant will always be a vertical line.
What do you mean by constant?
A number.
Isn't that,
So constant is a number without a variable.
oh, okay.
If it's multiplied by a variable, it's a coefficient. x equals a number is going to be a vertical line. And again, talk about intercepts. Let's talk about intercepts some more. What's my y-intercept? None. What's my x-intercept? -2, 0. And then tomorrow we'll talk about slope of these lines.
Wait, so that C stands for constant?
Constant. It's just a number, any number. (3x minus y equals 0). Let's find our intercepts.
Both?
We're finding both x-intercept and y-intercept. So let's find x-intercept, or let's find y-intercept first. We've been doing y. So let's find y-intercept first. How do I get my y-intercept?
Set X to 0.
Okay. So I get 3 times 0 minus, try that again, minus y equals 0. That goes away. Negative y equals 0. Y equals 0. So what is my y-intercept? 0, comma 0. Okay. Well, if my y-intercept is 0, comma 0, what's my x-intercept? It's also going to be 0, comma 0. It's intersecting at the origin. So they both have the same intercept. Okay. We call this a proportional relationship. Okay, proportional graph. Proportional graph. It's a linear equation that passes through the origin. It's called a proportional graph or proportional relationship. So I can't graph a graph with only one point. I can't graph a line with only one point. So what can I do to get a second point?
Set another number.
1. X or y? So let x equal 1. And that'll give us another point. Since I can't use only my intercepts because I only have one intercept. They're the same. Okay? So let x equal 1. I've got 3 times 1 minus y equals 0. 0. Y. Negative y equals -3. Y equals 3. Okay? So now I have the ordered pair 1, comma 3. And now I have a new point. Got a new point, and then I can draw my graph. Proportional relationship is a linear equation that passes through the origin. The x-intercept and the y-intercept will be the same. 0, 0 is the only time that happens. Special types of linear equations. Yeah. I always start linear equations with points, and then we move into slope. We want to highlight slope. Slope will be tomorrow. All right. Now, midpoint. Okay. Where does this formula come from? I'm going to ask you a very, very important question. Oh, God, you're so smart. If I have the numbers 2 and 12, what number is right in the middle?
6.
Nope.
2.
Between 2 and 12.
8. 7.
7. What can you do with a 2 and a 12 to get to 7?
Just add them to divide.
Add them and divide by 2. Because we're finding the average. So when we're looking at midpoint, it's the average of your x's and the average of your y's. It's the average of the x's and the average, if I could spell, of your y values. So if I add two numbers together and divide them by 2, that gives me the number that's in the middle. Now, most of the time you're going to get a decimal or a fraction. Actually, it's going to be half the time. Half the time you'll get a fraction. Because if you end up with an odd number divided by 2, you're left with a fraction. That's okay. All right, you can leave it as a fraction, and then the other half of the time we'll get a whole number. So the average of the x's and the average of the y's. Midpoint formula, when we get to circles, slope formula, point slope form, all of these equations have very, very similar features in them, mostly because it's x1 and x2 and y1 and y2, and we're adding sometimes and we're subtracting sometimes. They're all derived from the same thing. They all actually kind of derive from slope in one way or another. And they're very, very similar. So understanding what this formula comes from is going to make it a lot easier for you to remember it. Midpoint is the average of your x's and y's. If you can find the average of some numbers, boom, you can do midpoint. Okay? So we look at these 2 points, and I want to find the average of my x values and the average of my y's. Average of the x and the average of the y's. Okay? What are my x values? -5, -5, and a +2. So -5 and a 2. And what am I going to do with those two numbers to find the average? Add them and divide by 2. Okay? Average of the y's. What are my y values? 8 and 4. What am I going to do with those numbers to find the average? Add them and divide by 2. So from there we just simplify. -5 plus 2. -3 over 2. You can leave it as a fraction. You can write it as a decimal. I don't care. Okay? Either one is fine. 8 plus 4 divided by 2. 6. And that's our midpoint. Average of your x's and the average of your y's. Add and divide by 2. Last thing I want to talk about is graphs. Okay, so now that we're dealing a lot with linear equations, there will be times where it may be more prudent just to put your equation into a graphing calculator, depending on what it is that we need to find from it. And so, being able to read the screen of your calculator is important, so you know what it is you're looking at. So I have a linear equation here. You've got your domain and range from -10 to 10 on your x-axis and your y-axis. It tells you your scale. Noting your scale is really important. So if our scale is 1, means that each of these tick marks is counting by 1. So it's important that you recognize that. Your scale may change. Sometimes it's 2, sometimes it's 5, it might be 10. Right, Victor? Oh, sleepy boy. Wow. You are out. You good? So, when you trace along the line, we see that we intersect our x-axis at -2. So that gives me an x-intercept of what? We trace along our graph, we see that we are touching the x-axis at -. So what's my x-intercept? What's my x-intercept?
-2.
There you go. Remember, x equals -2 is a vertical line. Your x-intercept is -2, 0. Where's my y-intercept based on this graph? 0, 3 for our y-intercept. So being able to read your graph. Now, most of the time, graphing it by hand is going to be faster for some of these things when we're dealing with linear equations. When we get into quadratics and some other higher order functions, and the graphing calculator allows us to speed up that process. Looking for key features, so being able to read the graph is important. Make sure you're looking at the correct features. That's it. Questions, comments, concerns? All right. So you do have an assignment on